Okay, this is the third video to go along with our solving systems of equations with substitution. And so what we're going to look at now is what happens when we get something kind of funky when we're trying to solve this, like something that doesn't just give us a distinct solution, like where you just get x equals this or y equals something, right? We get something else. So let's see what that looks like. So the first thing we got to do is we have to look at this and say, okay, well, I don't have one of these solved for just one variable. So let's pick one of them and let's monkey around with it. So let's do this one right here. So let's take x plus 5y equals 4. We are going to solve for x because it's the one that's the easiest to solve for, right? So let's subtract 5y from both sides. So then you get x equals 4 minus 5y. Good. Now, okay, we're going to put this, more specifically this part right here, into this equation wherever we see x. So we have 3 times, instead of writing x, we're going to write 4 minus 5y equal plus 15y. Not the equals yet. Equals negative 1. All right, distributive property, right? Always, don't get ahead of yourself and always just, do what's in front of you and trust the process. So 12 minus 5y plus 15y equals negative 1. And now, when I collect like terms, which we do before we start moving things around, I get this crazy thing where 15y and negative 15y cancel out. Right? These cancel out. So I'm only left with numbers. And the numbers I'm left with 12 equals negative 1. Now, I don't know about you, but in the universe that I live in, 12 does not equal negative 1, right? They're separated by 13 units on a number line, and it's just not how it is. So when you get a situation like this, where you get a variable that cancels out, then you say to yourself, okay, that is no solution, because there is absolutely nothing that you can do that will make that work out, right? Another name for it is called the null set. Okay, so you'll see both of those. There's a fancy little thing for the null set, right? Sometimes they'll do this and they'll put it in brackets and say, no, null set, right? That just means there's no solution. Right? No solution, I think, is the best way for me to explain it, because it's pretty self-explanatory. So one of the things I want to point out really quick before we move on to the next problem is if you look at these two equations, right? So let's look up here at these two equations, and if you notice that, hey, what would happen if I multiplied this top equation by a factor of 3. So if I decided, and bear with me here, and I'm going to do this with a different color, right? So if I did this with a 3, right, that would give me 3x plus 15y equals 12. And then I carry my bottom equation over, right, and I have 3x plus 15y equals negative 1. And when you have a situation where you have your x's and your y's all have the exact same coefficients, you're going to get one of two things. You're either going to get a no solution, or you're going to get an infinite number of solutions, right? All real numbers. So in this case, because if I know that this is equal to 12, and I know that the same exact thing is equal to negative 1, well, I'm saying it's equal to two different things. And that doesn't really work, right, when we're talking about functions, all right? We don't like that. so we don't play with that, and when we see that, we go, okay, that's no solution. All right, next. So I just wanted to show you guys that so you could kind of see that, so maybe save yourself some trouble in the future. All right, and the next equation we have here, we have x minus 5y equals 10. I have 2x minus 10y equals 20. Okay, so let's do the same thing. So let's take x minus 5y equals 10. Solve for x. So we're going to add 5y to both sides. So we have plus 5y So that gives me x is equal to 10 plus 5y. We're going to substitute into the bottom equation. So we will go 2 times 10 plus 5y. Hopefully you're getting pretty good at this substitution thing by now. Equals 20. All right, so finish writing it out. Do our distributive property. So we get 20 plus 10y minus 10y equals 20. And you can see that we've got another one of these weird cases here where my y's cancel out. And I get 20 equals 20. Now, this is a true statement all of the time. So when you see something like this, where your variables cancel out and you're left with an identity, right? That's what we call that one side equals the other. That is something where it is an infinite number of solutions. Another way of saying that is all real numbers. And we show it like that. That's what it means, all real numbers. Okay, now using the trick that I told you at the end of the last problem I did, you should have, hopefully some of you saw this and went, wait a minute, if I multiply this top equation by a factor of 2, right, if I go times 2 on everything up here, I don't know why it won't let me make that into a multiplication side, you would get 2x minus 10y equals 20, which is the exact same thing as the lower equation. So just to put that out, if you're like, huh? All right, so the top, this is the top equation. This is this one right here. If I multiply that by 2, I get the lower equation. And what you'll notice is that if that's equation 1 and equation 2, they are exactly the same. So, you know, I'm just making all kinds of mistakes here, aren't I? So this should have said 20, right? Because 2 times 10 is 20. So if they're exactly the same, then you have an identity, and when you have an identity, you know that's infinite number of solutions. So again, if you recognize this before you do all of this work, right here, then just stop and write your answer down, right? But make sure that they have to be exactly the same. Exactly. Like a sign can't be different. They have to be, everything needs to be exactly the same. Otherwise, it does not work. So I hope this is helpful to you. Go solve some equations. I'm going to have one more video that I'm going to make that's going to be going over, I think, or wait, no, you know what? No, I don't. I don't have another video. So here you go. Enjoy, and have a great day.